Welcome to Ask and Learn.
Hello. So let's solve this problem. So in this problem, we have to find out the values of the circuit element separately, and the given values are the voltage and the current. So what we have to find out is this circuit element separately. So first of all, we have to identify what are these circuit elements, right? So I am just writing two important points which we should keep in our mind. First thing is, if the current is leading from the voltage is leading from the voltage, then the impedance will be, the current is leading, and the impedance will be capacitor. And if the current is lagging from the voltage, then the impedance will be inductive, right? So now, first of all, inductive, right? Inductive, right? So first of all, how to identify whether the current is lagging or leading? So look at these equations very carefully, right? So if you will look at over here, what you have to find out is we have to first identify, or we have to compare it with the standard equation. So if we compare, what we have found is this is our omega t, and this is omega t. What? Right. Give me 1 second. This is our, I'm writing over here, right? This is our omega t, and this is our phi. Similarly, over here, this is our omega t, and this is our phi, right? So if you look at over here is the current is, if you are looking over here, the phase difference, by the phase, the voltage is leading from the current. Current is lagging from the voltage, right? So if you look at these points, if the current is lagging, then our impedance will be inductive. It means one of the element is inductor, and one of the element is resistance. Okay. So if this is our, let's suppose this is our resistance and this is our inductor. So this is our XL, right? Now we have to find out the values of these R and XL separately, right? So if you look at this is our maximum voltage and this is our maximum current. So the most easiest way to get the magnitude of the inductance is use this formula which I am writing over here. The magnitude of Z can be written as, and we are only interested for the magnitude, right? Because we have to find out the value, not the whole vector. So the magnitude of Z is, it can be written as magnitude of voltage by magnitude of current, right? Or the magnitude of maximum voltage by magnitude of maximum current, or the magnitude of Vrms by magnitude of, sorry, magnitude of Irms, right? So if we look at over here, we have the values of maximum voltage as well as the maximum current. So I'm just writing over here, we have the value of the V maximum is 180 volts and I maximum is 12 ampere. So the magnitude of Z will be V maximum, that is 180 by 12, I maximum, that is 12. So we will get the value of magnitude of Z over here from there, right? Okay. So if we solve it, we will get the value of magnitude of Z, which is equal to 15 ohm, right? So we have to find out, we have to find the value of Z, right? Now we have to find out the separate values of R and Z. So R and XL, right? So if we look at the formula for Z, magnitude of Z can be written as, the magnitude of Z can be written as under root R square plus XL, right? So if we put the value over here, what we get is 15 is equal to under root R square plus XL square, right? So if we further simplify, what we will get is R square plus XL square is equal to 15 square, which is equal to 2 to 5, right? So this is our first equation. Okay. Okay then. So now if you look at over here, we have two variables, R and XL, and we have only one equation. So we need to find out the another equation. So we have one more point, tan phi is equal to XL by R, right? You should keep in your mind. Tan phi is equal to XL by R, where phi is phase difference. Phase difference, right? So if you look at over here is the value of phi is, so go to the top of the page. This is 10 and this is minus 30. The phase difference is 40, right? So the value of phi is 40 degrees. So what we will find from here is the next equation is tan 40 degrees is equal to XL by R. So this will our second equation. So just put the value of tan 40 degrees. So the tan 40 is 0.84. So let's put it over here. This will become 0.84 is equal to XL by R. And then if you cross multiply, you will get the value of 0.84R is equal to XL. This is our second equation. So now what we need to do is just solve these equations first and second. I'm not going to the solve numerically, and I'm just writing the direct answer. You can solve both the equations and you will get the final answer, value of R and XL separately. Right. So just solve both this equation. You will get the value of R. So I'm just writing the final answer. So the answer will be, the value of R will be, R is equal to 11.47 ohm. And if you put the value of R over here, you will get the value of XL, which is equal to, XL is equal to 9.64 ohm, right? So this is our XL. But what we have to find out is, we don't find out the value of XL. We have to find out the value of L. And we also know that, I'm just writing one more point and then final answer. So the one more point is, the XL is omega into L, right? And as I already compare, you can see over here, this is our omega t. So the value of omega is 2, right? So just put the value of omega over here. So what you will get is, the XL, just put the value XL over here, 9.64 is equal to 2 into L. So the value of L is equal to 9.64 by 2, right? So this is our final value. So you will get the final answer. The final answer of L is 4.82, right? So this is our 4.82, right? So the final answer will be, I'm just again writing the final answer. So this is our final answer will be, L is equal to 4.82 ohm, right? So the things which I have written in the red color are the important point which you should keep in your mind during solving these types of problem. So just look at these points once again. So this is one point, XL is equal to omega into L. Another point is tan phi is equal to XL by R, right? Where phi is phase difference, right? And the most important point is, if the current is leading, then the impedance will be capacitive, and if the current is lagging, impedance will be inductive, right? So that's all. Thank you.